Senegal, Africa. The stairs of no return. From these stairs, many pedestrians walked across roads, highways, intersections, sidewalks, and private property. Smokers of America is proud to sponsor Many Particles to Cross, the amazing story of atmospheric pollution. We believe learning about our air helps us all connect to how our tracheas feel about what we subject them to on a regular basis. Many Particles to Cross is sponsored by Rabbi Manzi, USKidsProductions, the Raekwon J. Hutchinson Foundation, Smokers of America.
Air pollution is an epic story, our American story. We were paid to fund this program, so subscribe to our YouTube channel.
And viewers like you. Thank you.
I've spent most of my life searching for the answers to the most essential questions about the universe. The people I've met across this journey have given me wisdom and insight about these questions.
So, how much do I get paid for this?
I've traveled across the globe to find out about our world, how it works, what makes it so beautiful, and what will make it fall. Nature is a delicate thing, so fragile that even the smallest of particles can equate to a whole new atmosphere. How can we respond to an ever-changing, life-sustaining world like Earth? Well, let's just say that there are many mountains to climb, and many particles to cross. Today on Many Particles to Cross, we will be talking about the lower atmospheric regions and their composition, pure gases, natural and anthropogenic pollution, particle size, smog, and other major pollutants.
The atmosphere in which we live in is divided into two main sections. There's the troposphere and the stratosphere. The troposphere is where weather occurs and where we live. Even Mount Everest is located in the troposphere, and it extends from about sea level up to 10 kilometers. The stratosphere is where the ozone layer is located, and occasionally planes will fly in this layer. So what is the ozone layer exactly? Well, it's a layer of ozone gas in our stratosphere that protects the Earth from harmful UV rays or ultraviolet rays. So what gases, besides ozone in the stratosphere, are present here, where we live, in the troposphere? Well, there's oxygen, which obviously we need to breathe, and there's also nitrogen, which plants use once it's converted into compounds through a process called nitrogen fixation.
Now we're going to interview a local chemistry student and find out what he knows about air in our atmosphere.
So based on your knowledge, what gases do you know are present in our atmosphere?
Well, considering we thrive off of oxygen ourselves, I can assure you that oxygen is present in the atmosphere as well.
Indeed it is, about 21% of the atmosphere.
That's correct, yes. Let's see, nitrogen and carbon are thrown around the chemistry lab every now and then, so I'll bet you around $5 to $10 there's some of that floating around too.
Nitrogen actually is the most abundant gas in the atmosphere.
Correct.
However, carbon is a solid element. Now, carbon dioxide is present in the atmosphere in relatively small amounts.
Alright, so, Mr. Doctor, can you please explain what carbon dioxide is made of?
Carbon and oxygen.
Could you name two of the three elements that I've named?
Carbon and oxygen.
Now let me remind you that I am the most savage chemistry student 2015 for a reason.
Besides major gases like oxygen and nitrogen, many other gases are present within the atmosphere, in trace amounts, like neon, argon, krypton, and xenon. They are often used to make the glowing, colorful signs that you see outside of businesses.
So what do you know about the different kinds of pollution?
Well, there are two types of pollution. One, naturally, which can be formed by volcanoes, forest fires, and decaying matter. And then there's anthropogenic pollution, which is formed by humans, by us. More primarily by burning fossil fuels in factories and in cars.
So if anthropogenic pollution's been what's causing all the problems in our atmosphere, what have we as a society been doing to combat this issue?
Well, in 1970, we passed the Clean Air Act, which limits the amount of air pollution coming out of factories and automobiles. However, that wasn't really comprehensive, so in 1977, we amended it again to add even more stricter requirements.
Hang on a second.
So as a long-term smoker yourself, what kinds of things do you know about the pollution in emissions in our atmosphere?
Well, there's smog. That's a big one that we have.
So what kinds of smog are there?
Well, first there's industrial smog, which is created mainly by sulfur dioxide, which comes from things like factories because of coal burning. And then there's photochemical smog, which is from sunlight reacting with other junk in the air. I don't know what it's called, but it's still up there somewhere.
So how exactly is smog formed?
Well, it's because of this thing called thermal inversion. That's what it's called. And unlike how normally warm air goes up and cold air goes down, polluted air will get caught up somewhere in the warm air. It'll cause smog.
So what are the different classifications of pollutants?
Well, there's primary pollutants that are put directly into our air. And then there's secondary pollutants that are formed up in our atmosphere through different reactions.
Well, Sandy, it's been great talking to you.
So, how much do I get paid for that?
Although Sandy was able to give us some important insight about the causes and harmful effects of smog, she wasn't too sure about the major pollutants that exist outside of that. After doing some research, I was able to come up with
around me are familiar faces, worn out places, worn out faces.
First off, nitrogen oxides, which are 97% created by nature from bacteria and lightning storms, are a key component in the formation of photochemical smog. However, most natural nitrogen oxides are washed out of the atmosphere by rain. It's the anthropogenic nitrogen oxides formed in combustion processes that cause the real problems. Ozone, another major pollutant, when it gets washed into the troposphere from the ozone layer, is very difficult for us to control because it is formed through chemical processes in the atmosphere. However, it can cause major problems. Sulfur dioxide is 70% created through the burning of fossil fuels like coal and oil. Sulfur dioxide can greatly affect climate change. Hydrocarbons are created by both mankind, through oil refineries and incomplete combustion in engines, and nature, from certain trees in the methane released from animals when they flatulate. They can assist in reactions that create organic peroxides that are a major irritant in nature. Lastly, carbon monoxide, which enters the atmosphere from
Decaying organic matter
as well as incomplete combustion in automobiles, is extremely lethal when inhaled in large enough quantities. It is certainly a life-threatening pollutant to look out for. Too bad you can't see or smell this gas. Now that we've learned about the components, threats, and particles within our atmosphere, what can we expect to see in the future? Well, if we assume the worst-case scenario, massive amounts of carbon dioxide created from our dependence on fossil fuels will cause global warming, which heats the Earth above the level desired by nature due to greenhouse gases like carbon dioxide, leading to melting ice caps, rising sea levels, and flooding in coastal regions. If we were to increase the usage of chlorofluorocarbons, or CFCs, our ozone layer would become so damaged to a point of no return, allowing too much UV radiation to harm life on our planet. However, it seems like we are changing our ways. We are capable of switching from fossil fuels to non-renewable energy sources like wind, water, and solar power. The technology is here. The great minds of the thinkers from the dawn of the millennium and beyond will sculpt the future of our great planet, Earth.
Here is the list of things we had to sacrifice for this video.